In the last video, I introduced you to this parameter called the index of refraction, which is little lowercase n right here. And as we discussed, it's a number that's assigned to a bunch of different materials. Every material has one. We'll just stick with the most common ones here. And as you can tell, that as materials get thicker, and by thicker I mean imagine waving your hand through the vacuum of outer space versus air versus water versus glass or something. It actually kind of hurt to wave your hand through glass, I would think. Well, but as you do that, the indices of refraction get larger. And so the science behind the law of refraction is this one. That theta 3, which we were concerned about in the previous video here, is related to theta 1. It is, yes. There's definitely a yes on that. It's definitely related. And the relationship is going to be this way. It turns out you take n1 and multiply it by theta 1. That's always going to be about equal to n2 times theta 3. Let me explain where that's coming from here. So this is sort of an equation here that we're not really going to use too much, but this is the general trend that we're talking about. So what we're talking about with these parameters here is, once again, you have your surface and you have your light ray. Comes your light ray coming in like this. And you have your normal to your surface right here. And as we discussed, this is like a little error, as we discussed, the law of reflection takes care of itself. We calling that theta 1 and theta 2, so that's theta 1 and that's theta 2. Those are equal. That's the law of reflection that we're all used to, takes care of itself. Our concern at the moment then is, what is this refracted angle down here, this bending in here? And if I extend the normal just a little bit here, let me just sort of magnify this a bit here. If I extend this normal to go down like this here, this theta 3 that we're talking about is this angle in here. In other words, what is theta 3? Because there's still the same normal in there. I got the normal in there. And we have this light ray which is going out, so we want to know what theta 3 is. And so you can see that in the definition up here, I've got the theta 1 and the theta 3. There's the theta 1 and there's the theta 3 that we're curious about. What are n1 and n2? Well, n1 then, it turns out, is the originating material, and n2 is the materials going in. So you sort of have everything pretty well parameterized up here. So the original material is n1, and this is material it's going into is n2. So as we said, n1 maybe could be something like, in a case like this, n1 might be water, and n2 might be glass, or n1 might be air, and this might be water, you know, something like that. So that's sort of the question that you ask when you concern yourself with how this light's going to refract is, what is the light coming from and what is it going into? And that's exactly what this law sort of describes up here. We say, hey, what are we coming from? That's the material N1. What are we going into? Like that. And this is sort of the ingoing angle. And there's our magic theta 3 right there. So if we did a bit of algebra on this here, we would see then that theta 3 is going to come out to be equal to n1 over n2 times theta 1. So this is sort of our key equation that we have to work on now. n1 over n2 times theta 1. So let me just maybe put some numbers in here. Let me copy on here. n1 over n2 times theta 1. This is the trend that we see in refraction. Okay, so let's just work on a little example here, and I'll give you some trends that we'll go with. Okay, so suppose n1 is air. In other words, I have a light ray in air, and suppose n2 here is water. This is like the swimming pool example. And suppose that I launch the angle in to the whole situation at, say, 45 degrees. Okay, I could do something like that. So what that's going to do then is a scenario like this. So here's the water right here. Here comes the light ray in. I've been keeping my normal sort of in this gray color right here. And what I'm telling you then is that this angle in here that it goes in is 45 degrees. Okay, there's my N1, there's my N2 right there. And then I get the ray refracting like this, and this angle in here that I'm concerned with here, that's the theta 3 that I'd really like to know what the angle is going to be. What angle, in other words, will it refract into the water with? Okay, so you can just sort of plug numbers into the equation there. Well, N1 I said was air, 1.1237 over N2, which is water. And if we go back to the chart here, water has an index of refraction of 1.33. And you have this times 45 degrees. So what you can pull from this then would be actually that ingoing refracted angle which is going to be about 34 degrees. So there it is. There's our relationship. There is that refracted angle. So in this scenario here, if I was going to blow this up like crazy here, this angle right in here of theta 3 would be 34 degrees. So in this case here, the light ray would go in at 45 degrees and refract into the water at 34 degrees. So that is an example of how we could figure out then exactly what the refracted angle is going to be. So it is true then that theta 3 is related to theta 1. Like, this is a true statement now that you should sort of accept then, that the law of refraction does depend on all this setup that you do to get your system to go. So it does depend on that ingoing angle, and we can see here that a 45-degree angle into water from air gives us a refracted angle of 34 degrees. We're not going to be too concerned with exact numerics like this at all. I'm just trying to give you an example. And in the next video, I will just show you two important trends that you do have to remember about the law of refraction. Then we'll be back on to some astronomy.